I wasn't sure if I really wanted to make a video specifically for this topic or not, but I think it couldn't hurt. Because one thing that's really useful about Maxima is matrices, if you understand how to use it right. Most likely you won't be using lists a whole lot, at least not directly, but they can be very useful from a programming perspective. And later on we're going to be programming scripts, so you'll see that they come into play sometimes. Sometimes they can be helpful. Um, and I actually did use these lists in a cryptography class. I used lists to represent, so I had like a list of letters that I could represent as a number, so I can encrypt or decrypt them and return a message as another list. So lists actually kind of come in handy when you least expect them to. So lists are written inside brackets. Let's define L as a list, and I'll say it's a 48279. I just made that up just now. So this is my list, 48279. Now, as you can kind of see, individual elements in lists are, so lists are inside these square brackets, and individual elements are separated by commas. Now, mathematically speaking, what Maxima calls lists is what we would call, or at least what I would call, a finite sequence. So that means that order does matter, and so does multiplicity. There's a lot of functions involving lists written in the manual, so many so that I really don't want to go through them all. That would take a very long time. So that, but there are some that are definitely worth mentioning. The first is that you can join two lists together. Let's take, okay, so we already have L. Let's define a different list. L2, 5, 8, 2, 1. So we have L and L2. And you can join two lists together to make a new list using the append command. So we're appending, get the cursor out of the way, L and L2. So now we have a list that starts with L, 48279, and then has L2, 5821. So you can actually use this command to add an element to the list. Let's say I want to add 3 to L1. Well, I can say I want to redefine L as the appending of L with 3. Oh, but I don't want to just have 3, because both of these have to be lists. So that means I'm going to append L with the single element list 3, and then I'm going to redefine it as L. So let me go through that one more time. I'm appending L with 3. So just like up here, this took L and added L2 to it. This is going to take L and add 3 to it. Now I listed this 3 as a single element list 3, because otherwise it won't recognize it as something that should be used as an append within the append command, and after that I'm going to redefine it as L again. So that means that now L has 3 on the end of it, so I can call it back up again and it'll come back as 3. Now you can also have lists inside of lists. So I'm not going to assign this to anything, but we can have 3, 4, 2. That's the first element in the list, and then 7, 8, 1. Let's go ahead and add another list to that. 13. So now I have a list of 2 lists. So you can have lists inside of lists. Now you can return a specific element from a list using brackets. What I mean is, let's say I want to say what's the third element from we had this L up here. We still have, I'll go ahead and delete some of this unnecessary stuff. So we have L. We want to find out what the third element in L is. So I can say L, and then in brackets 3. There's nothing in between it. It's just L brackets 3, and it returns the third element in L. Although I just realized that L is now, I forgot, has a 3 at the end of it. So this is our new L. This is our deprecated L. So this tells us the third element of L is going to be 2. Now there is actually the manual never explicitly says this, at least not that I could see. I don't even remember where I learned this, but this is something that's very, very useful to know if you're dealing with lists. The manual has a lot of weird things. It has you can actually write out third of L and it'll return 2. You can do fourth of L and it'll return 7. But that, as you can kind of imagine, can be kind of tedious, and it is not at all programmer friendly. So you want to have this instead, where it just 3. Well, you can do L3 or L4 or L5. And there's also one more. This one actually is kind of handy. You can do the last of L, and it'll return the last element. Now, what was the next thing I want to talk about? So, at any rate, one more thing that you can do is you can return the length of a list. So if I want to do length of L, I need to clear that off. This tells us that there's 6 elements in L. So you have 1, 2, 3, 4, 5, 6. Let's return the length of L2. 4. So go back up to L2. We have 1, 2, 3, 4. So there's exactly 4 elements in L2. Again, this is something that will come in handy. Most things that you use with lists is stuff that you would use mostly in programming stuff. And that's all of the things about lists that I want to talk about. But a natural extension of lists is matrices. You can see a lot of matrix commands from the algebra menu, including just entering matrices. It's enter matrix. Most often, I enter my matrices manually. It's just because I'm doing it so much. I've never actually looked at this before. But here's the prompt of entering matrices. I'm going to do this. I'm going to put in random numbers. So here is my matrix. And you can see the syntax for it. It's you put in matrix, then open parentheses, then the first row as a list, separated by a comma. So you can kind of think of a matrix as a list of equal length lists. And I'm going to go ahead and assign this as M. So now I can, oops, that's uppercase M. So now M is assigned as this matrix. So you can see a lot of the matrix commands from the algebra menu. So you can invert the matrix. You can transpose it. That's actually the transpose of the inverse. This is obviously not. I cannot remember the word now, but there's a word whenever the transpose and the inverse are the same thing. Orthogonal. That's it. Okay. And you can find eigenvalues, eigenvectors, and there's also a few list things, and you can actually relate lists and matrices. So there's also a lot of stuff in the manual that's not listed anywhere here. Let's see a few different things. Here's kind of a weird limitation for Maxima. Let's take this and you know what? I'll go ahead and show something else that you can do. I want to take in, and I want to assign this as appending M to matrix 4, 5, 6. Okay, hopefully this wasn't too sudden. You can use the append. Actually, maybe you can't. Let me see if this will work. Yeah, that was not smart. Forget I did that. It's not append. It's add column. That's what it is. So now that I cleared it, that's for a different time. We'll come back to that later. So forget I did that. But let's go ahead and I'm going to create a new matrix within. I'm going to add, and you'll see why I'm doing this in a second. All I'm doing is I'm adding some terms, because now it's a 4 by 3 instead of a 3 by 4, because I want to do something. I want to find the echelon form of that, of n. Now, Maxima has another weird quirk. I mentioned another previous quirk in a couple of videos ago. Here's one more weird limitation of Maxima. It has echelon form. It does not have row echelon form. It does not have reduced row echelon form. It has row echelon form just fine. But for some reason, reduced row echelon form is not a built-in function for Maxima. It's kind of strange, I thought. But thankfully, there is a plugin that does reduce row echelon form for real valued entries that you can find through Google, and we'll get to plugins later. Now, if you want to make a separate copy of a matrix, you actually need a special command, and that command is copy matrix. So if I want to assign this to R, so now R. And the reason why is because if you just assign R to N, then if you change N, then R will just go back to the changed N. So this, I know that seems kind of strange, but if you want R to be distinct from N, then you want to go ahead and use this copy matrix command. Otherwise, to be technical, you'll have two different variables that point to the same matrix. Now, you can add and subtract matrices easily. So let's take R. I'm going to redefine. I'm going to make a whole new matrix because I want to do some different stuff. I'm going to make something a completely new. Oops. So this is going to be my new R. The reason why is because now I have M and I have R. So this is M, this is R. And I want to have this so that I can demonstrate matrix operations. So if you want to add, you can add and subtract matrices easily. And you can multiply it. But there's something very important to know about matrix multiplication in MATLAB. If I just did M times R, all it did was it multiplied every individual term, I think. Not quite. I'm not sure what it did there. It just added them a little. I don't know what it did. But at any rate, this is not matrix multiplication. To do matrix multiplication, you do a period. This says to do matrix multiplication. So that's something to keep in mind. Otherwise, you'll get something different and something that's wrong. You can also do some row swapping and row operations. So if I want to row swap M, if I want to swap the first and second row, this took M and M. So it's M here. Okay, let's just show M as well. So this is the original M. This is the original one. This is the first and second row swapped. You can also swap columns with the I think you can. I may just be making this up. It wouldn't be too hard though to make a. Oh, I guess that is not a real command. All right, forget that then. And you can do row addition and multiplication by using the row op command. Let's see if I remember how to do this right. You want to, here's M, and you want to multiply. Here, I actually had this out somewhere. Let's see if I can find it. Okay, so you want to take the first row and the second row and 4. So what I did here was I'm taking the first row. This is the row that I'm going to replace, and then I'm taking the second row, multiplying it by 4, and adding it to the first row, and then replacing the first row with it. That's an elementary row operation. If you do much with if you're in a linear class, you may not have followed that very quickly, but it's still you have a basic idea of what that means. I just took this. I took this. Well, actually, first I took this. I took this, multiplied it by 4, added the result to this, and then replaced it with the new result. So this is that new result. Maybe I subtracted. I'm sorry, I subtracted it. What am I thinking? So then let me go through that again. I took this, multiplied it by 4, subtracted it from this, and then replaced the new version with that. Okay, so hopefully that was not too confusing. You can also, also there's no command for scalar row multiplication for some odd reason, but if you put your mind to it, it would be too difficult to write a plugin for it. But that's for a different video, because we haven't written plugins yet. Okay, so you can also add a row or column to a matrix using the add row command. What I tried to do a second ago using the append was completely wrong, and I should have known better. So let's do add column to M, and we want to add this 4, 3, 2, 3. I hope I did this right. Yes, I did do it right. So that means I took M. I'll delete that. I took M, and I just appended. See, this is a. You'll notice that each individual term, these are each rows. So that means that this is a column. Here, I'll write that out separately just so you can see it. So this is just a column vector, 4, 2, 3, because each thing in brackets is a row, so that means this is a row break, you might say. So this add column just took M and added this onto it. So if I wanted to make this the new M, I'd say M colon add column, and that would reassign M to this new matrix. Now I don't want to do that because I'm not quite sure if I'm done with this. So and you can do the same thing with add row. You can have add row to M, and now we can have 4, 2, 3. Oh, that's not a bracket. I don't want a curly bracket. I want a crud square bracket. Oops. So now I added a row to the bottom of it. Also, it will always add to the bottom row or to the right column. Now, there's one more pretty important thing. If you do ident like 5 or something like that, this returns the 5 by 5 identity matrix. If you want to do 3, you'll do the 3 by 3 identity matrix. So one more thing. You can go back to M. Just like with lists, if we go all the way up to the top, we can find lists using a specific value of a list. So this L is 1, 2, 3, 4, 5. This L5 returns the 5th element of the list, which turned out to be 9. You can do the same thing in matrices, but you're going to have a slightly different. Let's say I want to get this right here, this 87. So we can do M, and then in brackets 2, 2, return 87. If I want to get this 2 here, it's row first, so the row's the same, and then 3, return 2. If I want to get that 7, it'll be 3, 3. If I want to get this 71, it'll be row 1, row 1, 2, return 71. So I don't want to go into any great detail for most of the other stuff regarding matrices, just because that would make this video take forever. But I will say that you can find a lot of great stuff through the manual. The manual has 2 different sections on matrices. Just do a Control F and look for what you want to find. And there's oh, here it is. There's a few more things that we didn't get to. Like, we didn't talk about characteristic polynomial or eigenvalues or anything like that. So that concludes everything that I have to say regarding matrices. So I will see you in the next video.